Most of the riverbanks are composed of sandy soil, which is highly porous and irregular in the size of their grains. During the monsoon and high tides, these soil particles come loose and are washed away. The riverbank or dike does the job of holding back water. During high tides, the water level rises, resulting in an increased pressure over the wall of the riverbank. This causes seepage of water through a number of fine capillary channels. When water recedes, the soil and sand particles are carried back with the ebb. This sets the soil to wash away, with water going back into the river. This is a major reason of what is popularly known as soil erosion. But it can be largely prevented by covering the banks with geotextile sheets. Before the sheets are laid, the soil is dressed to make the bank surface uniform and smooth. This uniformity is important for the geotextile sheet to touch the soil surface underneath. Geotextiles can be applied in the construction of river embankments or dikes steeper than the conventional embankment. This saves much cultivable area and on the use of expensive construction material. A horizontal entrenchment is dug at the base of the riverbank. Using long sandbag tubes helps anchor the geotextile sheets strongly over the embankment. Geotextile sheets are formed by interweaving polypropylene and jute threads. The riverbanks are wide and need a couple of sheets to be stitched together to cover its large surface area. Polyester or polypropylene threads are used. The large geotextile sheet is now placed to cover the surface of the riverbank. It passes through the entrenchment. Long sandbags are now placed in the entrenchment instead of common single sandbags. This is done manually by pouring sand through one opening of the long tube. As the bag unfolds, it continues to increase in length. The long bag sits heavily and does not get displaced during flash floods or high tides. Sometimes nets made up of coconut fibre are placed over the geotextiles for better silt deposition at their grooves, as well as for reducing the topsoil erosion. This is followed by placing a number of bamboo sticks to make the geotextile sheets adhere to the soil surface firmly without any air gap, fold or crease. U-shaped iron rods are now hooked against the bamboo sticks. Sandbag tubes are also placed vertically over the banks at intervals. This further anchors the geotextile sheets placed below. Soil is now spread to cover the geotextile sheet, which is followed by the sowing of grass seeds. Waves of water drive the soil particles that hit against the dike wall. Under the action of lateral force of water, the permeable geotextile sheet allows some parts of water to pass through in a reduced pace with much lower thrust. With more waves splashing onto the dike wall and receding into the river, the soil particles realign themselves under the bank's earthen structure. The physical force of water moving back and forth makes the particles align in a definite manner. With the larger and heavier particles on the right of the aggregate of the finer and smaller particles. This realignment of particles leads to the formation of a filtering material within the earthen structure of the river bank. This is referred to as cake. This cake acts as a natural filter and lasts for years. The cake forms because of the geotextile sheet laid earlier. This cake gives immense strength to the inner wall of the river bank and prevents the possibility of collapse. As the channels flow the water back and forth through it, particles under the same physical force get realigned and create filtering material or cake at the twists and turns of the capillary channels. This reduces the water flow, which in turn prevents the swelling of channels within the earthen structure, a cause of riverbank collapse. After a few months, grass seedlings are seen on the river embankment. Grass grows and covers the whole area of the riverbanks with greater anchorage of the topsoil and bottom soil by passing through the geotextile sheets. The thickness of soil over the geotextile is about 5 centimeters. As the grass seedlings grow, their roots go down from the top soil layer to the bottom one. This takes nearly a month. By this time, the portion of jute in the geotextile sheets starts decomposing, leaving pores in between the polypropylene or polyester threads within the mesh. This creates numerous openings in the geotextile sheets that allow the roots develop vertically further down. Thus, the root system of all grass seedlings penetrates the naturally created pores of the geotextile sheets and the anchoring soil underneath. This reinforces the sheets over the earthen riverbank and leaves virtually no scope of their displacement. The grass cover acts as a shock absorber against the high tide and even in flood-like situations. This shows two areas of the riverbanks, one created with geotextile sheets and grass mat coverage, and the other with none.